100. So 10 to something is going to be 47. What? Yeah, it's going to be somewhere between 1 or 2. And so we're going to have a decimal. So what we are going to do is, let's graph, go back to our graph and say y equals 47. Okay, could we use trace and then figure out what the x value is when I'm going to just go trace.
It's not showing.
So does it make sense that it's going to be about 1.6 or thereabouts? Okay. Lorraine? Yes?
Well, this isn't like exactly about this, but is this stuff going to be on our final?
The beginning parts of it, yes.
And will you give us a list of what's going to be on
Yes.
our final?
Okay, so yeah, I'm introducing you to logarithms. I'm spending today, tomorrow, and maybe the beginning of Friday. But on Friday, I will give you a list of what you are responsible for. Okay, so what this is, we now know that this is 10 to the what? 1.6, 5, let's say, or 6 is equal to 47. Well, that can be pretty tricky to solve if you don't have a graphing calculator. And the graphing calculator has been around for maybe, I don't know, 20 years, 30 years.
But that's why you had to skip one.
Pardon me?
That's why you had to skip
Yes,
one.
I know, but you need to be able to know how to work with logarithms. And so, let's rewrite this in terms of my x. Wouldn't it be nice if I could rewrite this and have this as x is equal to 1047, and what I am going to be doing is solving for my unknown. And when we use the inverse is what logarithms are about. Okay, so we're going to use a logarithm to solve for an unknown. Okay, big picture. Everybody get the big picture. So we know that we have inverses, and the inverses are that I have my exponential function, and all I did with my exponential function is that I am changing my x and my y value. So I'm coming up with a new function. Okay, that's the big picture. So this is where we're going. I hope I can, as I said, I'm really trying to slow this down for you. Don't worry about what we don't cover for next year, because I've told Mr. Strasser and Ms. McNichol, or whoever you have next year, it is what it is, and I've taken you as far as I can, and they will pick you up where you can, okay? So the inverse of the exponential function, yes?
I was just wondering, are you and Ms. McNichol doing the same thing you did for the midterm?
We will have the same exam. Okay? Y equals 10 to the x. Is that a problem? Okay. Y equals 10 to the x, and is the function, the inverse is going to be x is equal to 10 to the y. Everybody so far so good? Okay. But this function is usually written as y equals logarithm, short for logarithm 10, okay, to the base 10 of x. And this is an example of a logarithmic function.
Why is the 10 so small?
Because it's a sub-number. So it is written below the line.
Oh, and an x is normal size?
Pardon me?
The x is not an exponent.
No. And I'm going to explain to you what these parts mean. Okay, and that's an example of a logarithmic function. Okay? So, I want everybody to repeat after me. I'm going to say it 3 times. A logarithm is an exponent. Again, a logarithm is an exponent. What is it? A logarithm is an exponent. It's very easy to kind of get lost in this little maze. And so you just need to make sure and put a little star that when we're looking for a logarithm, we are looking for a what? An exponent. Okay, so hold on to that idea. A logarithm is an exponent. Okay?
At the very top, it is the inverse of the exponential function
Of n.
of n.
And, okay, doesn't matter. Okay.
Can you go talk quickly?
The inverse of the exponential function y equals 10 to the x is the function x equals 10 to the y.
Okay.
Okay? And this function is usually written as log to the base 10 of x. And that's just an example of a logarithmic function. And so, what are we looking for?
An exponent.
We're looking for the which exponent?
Oh.
That one, right? That's what we are looking for. We're looking for the exponent. Okay, so, and this again, I suggest that you write this down. A logarithm is an exponent, and we have y equals the log base b, whatever the b is, of x, okay, is the answer to, and the question is, what power must b be raised to obtain the number x? So the answer to this is what we're looking for. And we're looking for, remember, what is the power, the exponent, that b must be raised to obtain the number x? Okay, so if I'm going to just move this over for you a second. All right, and I'm going to give you some vocab that we're going to agree on. I think everybody's good with 10 is the base, right? And 2 is the exponent. And I'm going to refer to 100 as the value, okay? Sometimes you will hear this referred to as the argument. I don't generally use that vocab, but we can agree that we have a base, and we have an exponent, and this is the value. Okay? You're really learning a language right now. Okay. Are we good? All right. So, this is, I'm going to read this, the log. Okay, remember, we're going to agree that this is our base, whatever the base, log of base, whatever, is equal to this value is going to be our exponent. So base, exponent, and value. And if anything, if you need to, just write BVE. BVE. I am looking for the base, the value, and the exponent. And these are going to be what I am looking for, my base, value, or the exponent. Okay?
Wait, but
What?
when we had it written up here before, wasn't x what we were, the exponent that we were looking for?
Yeah?
Like when you had 47 equals 10 to the x?
I used that example, okay?
Oh, so in this case, y would have been.
That's
the-
right. That's right.
Okay.
Okay?
Oh, wait, because you switched it?
Yeah.
Yes.
yeah.
All right. Now remember, in an exponential function, b cannot equal, b is going to be greater than 0, and b can't equal 1 in an exponential function. So if I have y is equal to 10 to the x, b has to be greater than 0. Do you remember y can't be?
Because that equals
Because
0.
that is an imaginary number.
Okay, then I have an imaginary number, right? That was, and we talked about that. And y can't be equal 1.
Because it's itself.
Well, what is 1 to the 10?
1.
What is 1 to any exponent?
1.
1. Am I going to have an exponential function?
No.
No. So can b equal 1?
No.
Okay, so you just need to kind of remember that there are certain parameters that are limiting you in terms of an exponential function. All right. All right, and again, in a logarithmic function, the base and the value are positive real numbers. Okay, so if I have this, these are going to be positive real numbers. That's just part of their definition. Okay, and y, I'll blow this up for